Hello everybody and welcome. And in today's video, we will be using our support tower from our previous video, and we'll be adding a stair tower to it.
Now, this stair tower will be occasional access, mainly for maintenance purposes. And that is important because that'll give us our minimum width for our stairs. When you're doing something like a fire escape, a stair needs to be at least 1.1 meter wide. If you're doing a two-way traffic, at least a meter. But since this is just one-way traffic, we can go as little as 750 millimeters wide. The next part is our rise. Now, generally, you are limited to about a maximum of 200 millimeter rise. If general public, basically anybody had to go up this stair, you try to go to about 175 millimeters high per step, and if it's industrial use, maybe about 190. But either way, you try to stay below 200. And the same with the going. Usually going, we have try to stick to anything above 250, and ideally for industrial use about 270, for general public about 280, but try not to get lower than 250. This is not going to be a solid steps, it's going to be steel steps, so we need about a 25 overhang between the steps. And our floor is 10 meters above the ground. Any stair is not allowed to be more than 3 meters high. Every 3 meters you need to have a landing. Landings are usually at least as wide as the stair, at a minimum of 900 millimeters. And of course you'll choose whichever one of the two is greater. In our case, we're going to have a stair that's 750 wide, so we'll need a landing at least 900 long, and of course as wide as our stairs. Now, if you have a look at your red book, chapter 12, it tells you everything you would ever want to know about stairs. We do have a avoided range between 7.1 and 22. You try and avoid if possible. Anywhere from 0 to 5.7 is for stuff like forklifts. Between 5.7 and 7.1 degrees is for wheelchair access, motor vehicles, pedestrians and such. Now, any stairs found in a public space where normal everyday people are going to access it, it has to be between 22 and 30 degrees. Next, we've got general purpose and fire escape. General purpose is basically any stair that falls into any category that isn't specifically a public building. Stuff like apartment buildings where there are other types of access. Of course, fire escape, emergency escape stairs, stairs at housing, all that type of stuff is between 30 and 40 degrees. Next, we've got the 40 to 45 degree range, and this is considered fairly steep access, usually just used for maintenance, occasional access, that type of thing. And then lastly, we've got the 45 to 50 degree range, which you should try to avoid if at all possible.
Now, firstly, we've got our flange on this side. We don't want our stair interfering with our current building, so let's see. This is a 457, so I think about 350 should be enough, and that gives us our stair nice outside, and so it shouldn't cause any problems. We can always move it later when needed. Next, we said we want a 750 wide stair, and then of course between the two stairs as it goes up, we need about 250, and then from there about another 750 for the other side stair, and we're going to put our column and maybe 175 out from that. That gives us a rough idea of where our stair needs to be, giving us a total of 2275. Right, I'm going to come over here and I'm going to say I'd like my next one to be not 2275, because that's, well, that's not a very nice, very round number. Instead, I'm going to make it either 2300 or 2500, roughly around about there. I also don't want this to be called C, as this is an added grid line. I'm going to call this B1. Get all those lines and just move them 25 up. Good. Next thing we're going to do is get a view on grid line B1. Nice thing about this view is we don't have any of the other stuff to interfere, and we can do a nice clean drawing from here. So again, we are going to go over to our construction line, and we are going to put a construction line way up here as well as down. Now we know that our platform has to be at least 900 and at least 900, and we know that our stairs needs to be at a maximum of 3 meters per flight. So we're going to select minus 3000, and we're going to have, I think, about 3 of them. Good. Now we've got our positions on each of our stairs. We can have a little bit of a flight here at the bottom, and it's going to go back and forth all the way to the top. Next, we are going to take a measurement from there up to that, and that gives us a beautiful 35.5. Now, as I'd like to use a standard hand railing that comes either in a 35 or a 40, I'm going to say, let's make this 40. This is occasional access only. There's not going to be a lot of traffic, so it doesn't really matter that much if we go up to the 40. So from here, I'm going to take one of these lines and copy, special, rotate, get 40, and copy. Now, the reason I'm doing this is I like my platforms to be a little bit more than what it currently is at 900. So take that there. Just move this in. It gives us a fairly nice platform or fairly large piece to work with. And of course, we can play around with that as needed. Now, if we head on over here to our components and we look upstairs, we'll find that there are 2 different ones. If you take the first one, the S71, and you go have a look here at the drop down, you'll find that we've got an open grid you can load up to use. Now, since we are designing the stair ourselves, the easiest is just to use the ones they give. Usually a stair would be something like 200 by 75 BFC, or you can go down to a 178 by 54 as suggested by your red book, but normal parallel flange channel much nicer to work with. So even if you have to go down, a 180 would be better. But in this case, we're not going to change anything over there. We're also not going to change any of the other stuff for now. Firstly, we want to put this in and just have a look at what it gives. Let's go over to symmetric, and it gives us a nice little stair over here. It looks fairly good. Don't see any problems. Next, I'm going to take a top view, and I'm going to put this right up against these lines over here, as the last stair is of course opening onto our platform. I want it to be on that side if possible. Next, I'm going to take this and I'm going to make a copy of it. Let's take our axes back to our curved plane and then do a mirror over center. Copy. So that we've got one going the other way. That one going the other way, we will select, move over to the other side, and we've got them next to each other. After that, I'm going to go over to the side view, and I'm going to move it down one flight. Now let's take this and increase our depth. So 2 meters. There we go. You can see both without seeing the background stuff. And I'm going to copy this top one down again. And I'm going to copy this one down as well. Select the bottom node using an Alt area select to shorten it. Let's go back, look here. Right, so our bottom stairs is on the outside, which is nice, gives it good easy access. Our top stairs is right up against, which is nice because it makes our top platform quite a bit smaller. It doesn't really matter what side it is, but smaller is usually better. Good. So from here, I think I'm fairly happy with what it turned out. So I'm going to open up the properties and we're going to start fixing up the rest of the stuff. Now, first thing we want to do is we want to add a distance for our grating. We're going to have a grating panels on top of this floor, and the grating is going to be, I think, an RS40, so that's a rectangular square, 40 holes, and it's going to be about 30 thick. So we have to add that 30 over here, and of course we have to add it at the bottom as well. This is so that positive 30. This is so that our stair top is the same with, well, same distance from top of floor to top of tread to top of tread, and so forth. After this, take these, just move them, expand down a little bit. Don't show this again, and do not expand. So after doing this setting, just go and move your stairs right up or down as needed. Okay. Next part is this little piece of overhang. Now we are going to have say a beam just there for it to go into, and we don't need a support beam over here, so we're not going to do anything over there. Therefore, that's fine. Next, we are going to look at our going and rise. So 176.5 rise with a 210 going. That going is a little bit too small. So let's make this 200. Take a new measurement. It's going to be 200 that, 234. That's still a little bit small, but unfortunately, with the way this stuff is, I don't think it's going to work out perfectly unless we change our slope. Now, what we are going to do is we're going to take that 238 and multiply by 200, and that's going to give us 47,600. And unfortunately, that does not fall within our ratio. Remember, we need to have at least 4,800 to 5,500 in order for this to be acceptable. So we'll need to change our slope a bit. Now, I'm going to take these bottom two and just delete them for now. Go up here and say, right, how far are we from there? Let's take both of these stairs, move them right up against, so that's 900. I'd say give us another 100, and take these two at the bottom, do the exact same thing, move them right up against, add another 100 right about, and say, okay, what is our new angle? Uh, 38 degrees. Well, that's a fairly good angle. Let's have a look at our treads. It's 160. Yes, that's definitely over the minimum. That is still on the maximum. And if we take these two and multiply them with each other, that will be 2 times 200. It does fall within our golden ratio, and therefore this stair is acceptable. Not the one I wanted, but acceptable. And at the end of the day, that's what we're aiming for. Right, copy this down, grab that bottom, and just bring it nice and level here. Of course, I want this one to keep. Nope. That is a P to there. Basically, even though this one is shorter, I still want it to stay within the same stair heights as the rest, these 200s. So I'm going to say, take this line, copy special, linear, let's clear this minus 200. Let's do it at 8 of them. There we go. Grab that, stick it over there. Right, so open this up, move that 30, move these so long as well. And let's see if we move it over there without the 30. Right, exact. Usually it's supposed to equally divide up if you've got the correct point, but as you can see, it doesn't always work perfectly, and then you might need to just persuade it otherwise. Okay. Alright, so now that we've done that, and our bottom thread is fairly what it should be, not exact of course, all these lines. Yeah. Next, I'm going to open up again, take all of them, turn off all of these. It is a 750 wide. I'm going to say, right, this is a M1, and it's going to be ST1 for stair stringer, and that's just so that my color, well, part marks and everything is correct. I'm also going to go down here and say thread is T1 for step or thread. No. And that'll prevent me from having to do all of this later. Okay. Next is going to be our frame for our stair tower, and that's going to be the columns and the beams we're going to put in. Now, I'm going to take these two columns exactly as is and copy them over, because I'm going to be using their heights, but I don't want to use their size, so I'm going to open them up. And because this is a fairly light stair tower, it's only got access stairs, they're fairly narrow, we are going to be happy with a 203 by 133. Of course, if there's any structural, anything structural that it's carrying, or if there's any vibration on it, anything like that, you will need to get your engineer to give it a once over and calculate the required stuff. But for us, this isn't necessary at the moment. Usually I find the easiest is just that if you've done a stair tower before, you can simply just use the same section sizes for a new stair tower that you're doing. Faceplate. In other words, condition-wise, not much difference. Using something that's already designed, much easier. Do note that if it's not calculated by an engineer and there is something that goes wrong, you are responsible for that. So, yes, you can, but it's not suggested. Right, 30 grout, the same as the other side, with the size of that. We've got a 16 plate will be good enough. Usually 16 or 12 for a 203 beam. It's going to be 2 holes, 150 apart. We've got another 50 and another 50 over there. Same with this, 2 holes, about 300 apart. About 50 there, about 50 there. Gives us a fairly standard sized base plate for this. It's just fine. We use an M20 for that, and it doesn't matter what our bolt standard is, as we're only doing holes. Roughly the same as that one over there. Now, the reason I did stiffness is because I don't want to put bracings in on I want to put bracings in between these two over here, so just stabilizing the stiffness a little bit. Again, something that the engineer will have to figure out for you. Usually, don't do it yourself. And this is going to be, say, about 160. So we do about 180 over there and about 90 over there. That should give us a fairly nice looking faceplate. I'd say 90, so that's 70. So we've got a nice 20 and a 20. Now that should work very well. Over here, I'm going to do the exact same thing. Good. Next, we're going to take a standard 203 beam that we used over here. And again, this is not going to be carrying a lot, so the 203 beam is good enough. Let's put it in from there to here. And 134. Of course, we want to get our settings that we've already done and just modify them over here. Saves us a lot of effort. Now, because this is part of the stair tower, it's no longer just a flexible end plate. It does need a little bit of moment. So I'm going to say, make this a full end plate. So 6 from top and bottom should work nicely over there. And let's stick it same this side. From here, I'm going to say, let's have a look at over there, and then copy it. Put it only where necessary. Leave the lines should have. Right. There we go. Now we've got it everywhere it's needed. This column over here does not need to be that high. It can stop right here. So look at it again. It looks good. Of course, that comes out enough. That comes out enough. Now, we are going to need to put bracings in between these two items. Same with over here, put bracings inside there. So, let's see, grid lines 1 and 2. For our bracings, I think it's just going to be for stabilization purposes. So the one we've got over here, the 70, more than adequate. And since we don't want to set it up from scratch, let's just get our settings from the stuff we've got that's existing. So we'll do that. Now, we don't need anything here at the bottom. It's too small of an area. And if we look at this area over here, it's about 3 meters high. Let's see, what is it across? Just need a rough estimate. 6.4 meters. The effective length that a 70 angle line can brace is only about 4 meters. So if we do a cross brace, it should be good enough. Now, I'm going to select these two over there. Run over to steel and put it in from point over there, that, and from over there to that. And then should be, yes, 3 meters. That should be fine. But for our bracing, that up there. Connection. Now, because of how far it comes out to the side, these ones just directly to the column, doesn't need to touch here. Over here, definitely to fixed to the beam, and if you shape it, this doesn't need to extend or anything like that. Of course, this one over here, a little bit different. We take these and we just move them to the middle. Basically going down and find that those shape. But okay, so over here again, it's right up against the column, doesn't really connect to that. So what I'm going to do over here is just take a normal line cut and get rid of this bit of the bracing. I'll just hide that so you can see more clearly. Also, I'm going to take this cut and I'm going to move it 20 up, and that'll give us a good little bit of clearance here so it doesn't really interfere with what we are doing. Next, one of these two are going to need to swap around so that it comes to the back instead of the front, and that gives us a nice little cross brace so that we can put a bolt in the middle. If we leave them to both face the same direction, obviously we will need to do a completely different type of connection. Nice full gusset, and split them and all that lovely stuff, instead of a bolt. Change the top. That's good. Yeah. That's fairly it for that side. Okay, we're going to do the exact same thing for the other side, which is split 2. Grab that, and grab this one. Now, the reason I'm selecting them is just for the points, as it highlights the nodes or the SOP points that I want to use, making it much easier to work with. Also, before I continue on there, that is no problem. Okay, let's get back to that. Right. Again, very simple. Just do that. It's just going to be over there. And there. Now, depending on how it's connected, where it's connected, you might have an SOP here at the edge instead of the center. It really does depend on how your engineer works out the forces of where the stuff should go. None of that stuff is worked out we're basically just we're just stabilizing it. It doesn't require a lot of that line. So I've got like so it doesn't interfere. And then this one over here, take a measurement anywhere over there, and we want it to be x, that is 122. So either 125 or 120. I think 25 looks good. To make it see-through, you can see that it clears both sides. Next, one of these two just swap around. These two swap around. It's good. It's good. Now, instead of putting the bolt in manually, you can of course use the cross, bracing cross under B. Select two, and it should put the bolt usually close to the middle. If it doesn't, you swap around the cone. So instead of Y, let's see, minus Y, nicely in the middle, and then we go to parts and we say 0. Because we don't want a part. Do be careful when using this, as sometimes the bolt might seem very, very close to being center, and you miss and it's not. Right. That will be it for that. That gives us our stair tower. Let's see. These ones need to connect. Now, I'm not really in the mood for another end plate, so let's have a little bit of fun here and put in, I don't know, shear plates or cleats. Let's see. Cleat, angle cleat, nothing. I think Tekla calls it a clip angle. There we go, clip angle. Clip angle 141. We open that up. Ah, yes, we've got stuff that we can load. That means it's a connection that's actually actively being worked on. Okay, that won't put in. We need to change it to object in components. There we go. Nice. As you can see, quite a horrible looking connection. So first thing we're going to do is I'm going to say, yeah, no, I don't want both sides, I only want one side. And I only want it to be on the inside. Next, standards are 70 down and then 70 between. 70. Right. Then our notch is going to be 35. That'll work. I'm going to say, let's do 25 notch, as this doesn't need to be that small. Let's see, 70 down, goes to a 70, 2 or 3 beams, so that works fine for that. I'm also going to say, let's use an angle line that we've already got on this building. So 90 by 90 by 10. Let's make this by 10 instead of by 8. Again, with like like with most of the stuff, like with the bracings and so forth, even though technically a different size might have worked better, 60 would have been sufficient. I'm using a 70 because I'm using a 70 at another place on the same building. Same with this. 8 is sufficient. I'm using the 10 thick simply because that's the angle line we're using at a different spot. Much cheaper just to get the offcuts, use that, then to get a completely new size. Right, good, that will work. Weld it to that, or we could say we weld it to the beam and just bolt to that. Doesn't really matter which one we want. Next, I'm going to say back mark on a 90 angle line is 50, not 55. And where they got theirs. Right, that should do it. I'm just going to quickly go to parts, and I'm going to say put it on the other side, and just apply the connection to all the ones. Now, I know for a fact that half of them are going to be wrong because, well, when you do something on one side of a channel only, whether you're putting it on the front or the back of the item, in other words, the start point, the end point. So on the end point it is correct, but if we look at this one, it's on the start point, therefore it's on the other side. So half of them are going to be other side. Simple enough. It's always going to be the same set. So now we've got a nice set of clip angles all on the inside. Right. Next thing we want to do is add base connections right over here. So for that, go into Stair and just get Stair base right on the edge, right on the edge. We have both of these, both of their nodes, to the side, and this one is again fairly simple. All we want to do for a start is put that to ground. Next, we want to move this back from there. Let's undo that first. Put this with lines, much easier. Over there. That's the point. Right. So standard rules are, well, whatever grout we've got grout. Back. Next, we cannot have this ending in a slope. That is a tripping hazard, so we want to copy this, get this back 100 at least, just to cut off the tip. And then, of course, we only want one bolt per side. It's going to be 10 thick. So, one bolt, and that's going to be 100 back. After that, select the nodes with an area select, and then we stick it over there. I think, let's move this another 100 back. Right, the bolt is still far enough from there to be good, and we've got this front area clipped off, so we don't have a tripping hazard. A little bit more than the normal 100. that doesn't matter. Right, this is going to be, let's see, in 20, make this the exact same in 16. Let's make this a chemical anchor, and I'm going to turn on the bolts. Good. So, where these bolts are going to be laid in on site, these are simply going to be drilled in, epoxying into the ground. So we don't need that big of a hole. Let's just swap these around. I don't like them going through the top. Although it really does not make a difference whether they go up or down. It's simply just a representation. But I like them going down. It just looks nicer. Now the last thing that we are going to do for this video is we are going to put a little angle line over here called a seating cleat. This is for the grating to rest on inside. Now we don't need anything more than a 50 angle line, but as always we are going to look at something that we are currently using everywhere else on the building, this 70 by 70 by 10, and we are going to use that for our seating cleat. Simply just because it saves material. Now, to start off with, put it right over here and make about 200 out. Bring it back 50. And that's all we need, is just a little bit of angle line right over there. We're going to lower it down. That's going to be up against the side. We don't need it to be called anything, as it is just a cleat. Let's make this nice and bright, different color. Okay, 3D. Now, we're going to move this here right up against the back over there. I want to lower it. Do. Apply the settings. We can just do the other way around. Grab that side. Let's do this side. Again, we don't want anything other than the X. And we want to weld it to our stringers. Copy this right in the corner, right over there, and right. To 50, right inside. And that should give us our seating cleats. Let's just have a look at our assemblies. Now, as you can see, our assemblies are angled, and that's because these sloping members are the main parts. Now, with the way the drawings are going to look, the way we want them to look, we want to use them. We don't want the main parts to be these. I'm going to take the top and change it to be the main parts. And that's just going to make our assembly drawings much neater. Save us some hassle. to illustrate the difference, I'm going to leave the bottom one as is, just to show you what happens if you don't do it. And that's it. Hope you enjoyed, hope you learned something. See you next time.